In constructing the fourth figure in the sequence, we should have no difficulty, although it is more easily shown than explained. Therefore, let us play a little game of show and tell. Of course, we need to show or to construct or to draw, represent the fourth figure in the sequence, and we make use of what we see there already. So the first pattern has a single square with its diagonals. The second pattern has two squares with their diagonals. The third pattern has three squares with their diagonals. So the fourth one will have four squares with their diagonals. Therefore, the fourth pattern will have four squares with their diagonals. There we have them. That's all there is to it. We need to complete the table for the rows that are indicated right there. 1, Roman 1 and Roman 2. And we are making use of patterns that we find in that table. The first number in each expression is the same as the number in the first column. So notice that we have a formula here, and in the first column the numbers are the same. Therefore, we'll imagine that we'll have a 4 and a 10 there. Therefore, in each row, the first number in each subsequent expression has to be the same as the number in the first column. So the number in the first column, the number in the first column, the number in the first column, and also right there. So 4 will be there, and 10 will be there. Anything else to notice? Yes. 6 is a constant value in each expression, so we always have 6 all the way down. So 6 goes there. And anything else to notice? The final number in each expression is always 1 less than the number in the first column. So we have 1 less than that is 0. 2, 1 less than that is 1. 3, 1 less than that is 2. Therefore, we expect to have a minus 3 right here and a minus 9 right there. And then the value that we get here is the result of calculating what we will get from these expressions. 4 6 is 24, minus 3 is 21, and 10 6 is 60, minus 9 is 51. So we'll imagine that we'll have 21 51. The third column has the equivalent of the expressions. 21 51, no problem. 4 6 is 24, minus 3 is 21. 10 6 is 60, minus 9 is equal to 51. And then what do we do next? The sequence starts at 6 and goes up by 5 each time. Consequently, the terms are related to the multiples of 5. So the first term is what? 6, which is 1 multiplied by 5 plus 1, which is 5 plus 1 is 6. What about 11? 2 times 5 is 10 plus 1. What about 16? 3 times 5 plus 1. So we notice that there's a constant going up like that by some multiple of 5. 5 1 5 plus 1 6. Then we have 5 2's 10 plus 1 11. 5 3's 15 plus 1 is 16. And then 5 4's 20 plus 1 is 21. Therefore, 106 must be some number multiplied by 5 plus 1, which is what we are saying right here. And we can just say it simply because we are saying that 6 is some number multiplied by 5 plus 1, 16 is some number multiplied by 5 plus 1, 21 and also 51 is some number multiplied by 5 plus 1. There we have it. So 106 is equal to some number multiplied by 5 plus 1, or 5 times the number. 5n plus 1 is equal to 106. And we need to solve that problem. So we subtract 1 from both sides, and then we finally divide by 5. So n is equal to 21. You see 21 here, you see 21 there, and you are tempted to say, how comes? But 21 is not the figure that we are talking about. The figure that we are talking about is this 21, which is supposed to be a number in this column, not a number in this column. The expression that we are required to write in D is the same as the one that we have right there, which is 5n plus 1. However, we will use the development of the patterns in the table to substantiate our claim. So this same 5n plus 1 we have right here is the 5n plus 1 that we have in the final part of the problem, but we will not just take it for granted. Although we have enough proof already, we will also take an algebraic approach to it on the next slide. The first number in each expression is the same as the number in the first column, consecutive counting numbers. Therefore, for the nth pattern, the first number in the expression will be n. What about the next one in the expression? 6. 6 is a constant value in each expression and will be present in this general expression also. So 6 will go there. And what else do we know? That the final number is in each expression is always 1 less than the number in the first column. In this particular case, it should be 1 less than n. 1 less than n is n minus 1. There we have it. Expand the brackets and simplify. Do not forget that the negative multiplied by negative will result in a positive. So negative multiplied by this negative 1 is going to be a positive. And what do we have? 6n minus n plus 1. 6n minus n is 5n. Put the like terms together. We have 5n plus 1. And that is what we discussed on the previous slide. In our previous presentation, there is a problem that is analogous to this one. It may be consulted for greater details in the solution of this problem. So this is problem paper number 13, and we have gone through quite a bit. The one that we have gone through is analogous to this one. It is not exactly like it in every single way, but the numbers are quite similar, and we will make use of the same pattern because, as a matter of fact, the sequence is very, very close, if not exactly the same. In making x the subject of the formula, because we are expected to make x the subject of the formula in this particular case, transpose this equation and make x the subject of the formula. In making x the subject of the formula, we find first we eliminate the denominator from the right hand side by multiplication. Well, flattening an equation when we are transposing is always a very good first step to make. Sometimes it might not be the very best, but it is always a very good one to make. Eliminating the denominator by multiplication. As a matter of fact, a denominator is something that we are dividing by, so we will multiply in eliminating this denominator. As a result, the left hand side will be multiplied by x minus 4. In the next step, y has to be multiplied by both x and negative 4, and we will proceed to do that. So in the next step, we will take advantage of the fact that we need y times x and y times negative 4. So we have xy minus 4y, and that is equal to that same thing there, 2x plus 3. Just putting them in alphabetical order. Xy and yx are the same, but more appropriate to write xy. And then what do we know? We are attempting to make x the subject. Therefore, we need to accumulate the x's on one side. Preferably, in this particular case, the left-hand side, it is not always the most convenient thing to do to accumulate them on the left-hand side. But in this particular case, it is the best thing to do. Then the other terms will be transposed to the right-hand side. So we have xy here. This one has an x, will go there, and negative 2x. This one will be on this side, a positive 4y. So xy minus 2x is equal to 4y plus 3. We took advantage of the fact that both of them will be positive to put the y first on that left hand side. What do we need next? With two occurrences of the proposed subject on the left hand side, we factorize in order to arrive at one occurrence. So we have two occurrences of x on this left hand side, and we therefore factorize to get one occurrence of x. So take out a common factor of x. What do we have? X into xy is y, and x into 2x is 2. Finally, in making x the subject of the formula, we need to eliminate this factor that we are multiplying by on this left hand side. And if we are multiplying by that factor, we will eliminate it by division. Consequently, the left hand side will be divided by y minus 2. So finally, we divide by y minus 2 in order to eliminate that factor from the left hand side. There we have what we have always wanted. I like the way that especially these section 2 problems are being stated. They are being stated in such a way that students will really have to have an understanding of the topic that they are attempting to solve the problem on in order to get close to the maximum marks of one of these problems. There we have the exact same thing right there, and we are required to use this to write down the inverse of a function. With the understanding of the way in which we arrive at the inverse of a function by transposition, we may make use of the fact that the result of such a transposition results in an expression that is equivalent to the inverse of the function. All we need to do is make the appropriate exchanges. So we were required to transpose this, and we have done that. Then we are required to write down the inverse of a function. And of course, we are accustomed to the process of finding the inverse of a function by transposition, which is the same thing that we are given here, except that we were asked to do the transposition first without considering the function, and then in the end make use of it in writing down the inverse. We know that the inverse is related to the transposition that we have just done, and all we have to do is just make the necessary changes. So we have f inverse of x is equal to, all we need to do is replace these with x, 4x plus 3 over x minus 2, and that is all there is to it. We also need to determine the value of x when f of x is equal to 0. F of x is 2x plus 3 over x minus 4. So when f of x is equal to 0, then 0 is equal to 2x plus 3 over x minus 4. Or we may say 2x plus 3 over x minus 4 is equal to 0. And then we will solve that equation. Eliminate the denominator by multiplying both sides of the equation by that denominator, and the denominator is x minus 4. So we are flattening the equation again by eliminating the denominator. The denominator is something that we divide by, therefore we need to multiply by that x minus 4. As a result, x minus 4 will be eliminated from the denominator of the left hand side. And since the right hand side is equal to 0, when we multiply that right hand side by x minus 4, the result will be 0. So, and since the right hand side is equal to 0, the result of multiplying by x minus 4 on that side will still be equal to 0. So 2x plus 3 is equal to 0, and that we solve. So still focusing on our x, which is what we need to find, eliminate the positive 3 from the left hand side by subtracting 3 from that side. And as a consequence, we need to subtract 3 from the other side. On the left hand side, 3 is eliminated, and on the right hand side, we have 0 minus 3 is equal to negative 3. Finally, divide both sides by 2 in our attempt to eliminate 2 from the left hand side. So eliminate 2 from the left hand side by dividing 2 by 2 on the left hand side. But we need to also divide by 2 on the right hand side. The value on the left hand side will just be x. X will be left on that side, and on the right hand side we have negative 3 divided by 2, which is equal to negative 3 over 2. We think that we will just be able to breeze through this problem because it is a linear programming problem in which the shaded region is given already, and we have the lines which are representations of those linear constraints, and we also have accompanying those lines their equations. But of course it is not as straightforward. We will have to have a very good understanding of the linear programming problem and go straight ahead and meet the requirements of these examiners. So in the first case, what do we need? We need to determine the inequalities that are representing that shaded region. So the region begins on the line 3y is equal to x. So it begins 3y is equal to x and continues above it. So the region begins on the line here, 3y is equal to x, and continues above the line. So what do we say about that region? 3y is greater than or equal to x. So the region represents values that are greater than or equal to those on the line because it begins on the line and continues above the line. So greater than or equal to those values that are on that line. So 3y is greater than or equal to x. What about that one? The region begins on the line x is equal to 6 and continues to the right. Values of x increase to the right. Therefore, the values are greater than or equal to 6. So those values of x are greater than or equal to 6. So what do we say? X is greater than or equal to 6. If an optimum solution exists, then it exists at one of the vertices of the closed convex set. So let us take a look at the vertices. 6, 2. And what about that one? 6, 34. And then the other one, 30, 10. Good. When I'm presenting linear programming to my students, sometimes they are amazed that I know where the vertices should be before. But in this particular case, especially for these two, should not be too difficult to determine where they should be, because this line is x is equal to 6. But everywhere on this line, the values will add to give 40. So if the x value is 6, then the y value must be 34, because 6 plus 34 is equal to 40. So it's easy to determine that. Also, for this one, maybe it's not so easy, but we can see that it's not so far-fetched that 3y is equal to x. So whatever the value of y is, the value of x must be 3 times that. In addition to that, they must have a sum of 40. So you are thinking about 10, and 3 times 10 is 30. So no doubt we have 30, 10. So it is not very difficult to tell where the vertices should be even without drawing the graph. So the objective function is the profit is equal to 4x plus 3y. The maximum value, because we are trying to determine the maximum value of that objective function, the maximum value is usually the one that matches the larger coefficient with the largest ordinate. The larger coefficient with the largest ordinate. So in this particular case, we have the larger coefficient is the coefficient of x. So we are going to try to find the largest x ordinate, and that is 30. So that one should give the maximum there. So the larger coefficient is that one that belongs to x, and the largest x ordinate is 30. Therefore, this one should give the maximum. But at the same time, we do not ignore the value of y. So we have the p for x plus 3y. So the maximum, we take 4. And what do we do with this 4? Multiply by the coefficient, multiply by the value, the ordinate of x, which is 30. And then this 3, we multiply by the ordinate of y, which is 10. So we have 4 3s 12, and 3 10s 30. So we are looking at 150 for the maximum profit. But we need to substantiate our claim. There's no simpler way to substantiate our claim than to show the values that you would get if we use the other ordinates. So this ordinate 6 34 4 6 3 times 34, by using this same function, we get 4 times 6, the value of x, and 3 times 34, the values of y, and we end up with 126. This one cannot give the maximum. 4 times 6 plus 3 times 2, which is equal to 30. So we see that the others are actually smaller, and that there is no other way or better way to substantiate our claim than to use the other values and show that they actually turn out to be less. So the other two values are less than the proposed maximum. Therefore, $150 is the maximum. Now for problem number 10. The regular hexagon affords us much convenience. Each angle at the center is 1/6 of the revolution because there are 6 equal angles at the center. And we are trying to find the angle AOB. And if we have one of 1, 2, 3, 4, 5, 6. So this is 1 out of 6, which is 1/6 of 360. So we have AOB, that angle is 360 divided by 6, turns out to be 60 degrees. And not wanting to forget, we will put that in there. We will put that in there at the appropriate time. The area of the hexagon is 6 times the area of one of the equal triangles. So we have 6 equal triangles, and the area of the entire thing is 6 times the area of each triangle. The area of one may be determined by considering that the length of each line from the center is 5 centimeters. So each one is 5 centimeters. And recall that the angle AOB is 60 degrees. What do we do? The area of any triangle may be found by taking half of the product of any two sides, and by also multiplying by the sine of the angle that the two sides form. This method may be applied because we have two sides of the triangle and the angle that the two sides form. So the area of each triangle is what? Half the product of the two sides, 5 times 5, because 5, this side is 5 and this side is 5. This side is 5. So multiply that by sine of the angle that the two sides form, sine 60, and that is what we will get. A half, 5 times 5, sine 60. Do not forget that we have 6 of them. So that turns out to be 75 times 0.866, and that gives about 65 centimeters squared. Recall also that we need to find the area of the hexagon that consists of 6 of those triangles. So we find the area of one triangle and we multiply that by 6. We do it in the same step. Multiply 6 by the area of each triangle and we will get the entire thing. And that's all there is to it. But we have a lot more to 10 part B. The angle of elevation of P from K is 28 degrees. The angle is therefore located at K. Also, any line on horizontal plane is perpendicular to a vertical pole. For example, PK is on horizontal ground. It must be perpendicular to that pole, PL, or we may call it LP. So that should be a right angle, as it is required of us in the statement of the problem to include one right angle in the diagram. At least one of them, because we have more than one. We have another one over here. So we are saying this is supposed to be a 3-dimensional figure. And K, P, M are points on horizontal ground. And we have a vertical pole here. So where K, P meets this pole has to be a right angle. And also this one must be a right angle. But we're just making use of just one of them. So this is a right angle. All of these lines, these 3 lines are on horizontal ground, and this is a vertical pole. Any line like this on the ground that meets the pole will therefore be a right angle, because vertical and horizontal meet at right angle. And let us include also that 28 degrees angle. We need to find LP, and KP is 15 meters. Put in that 15 meters. We need to find LP or PL. This one we need to find, and this is 15 meters, and this is a right angle triangle. The line KP is on a horizontal plane and the flagpole LP is vertical. Horizontal and vertical are perpendicular. That makes triangle KLP a right angled triangle. So there we have the right angled triangle. LP is opposite to the known angle, and the known side is adjacent to that known angle. We have opposite and adjacent. Let us apply the tangent trig ratio. We have opposite and we have adjacent. We need to find this. This one is opposite to this angle. This one is adjacent. Opposite and adjacent is tangent. And tangent is equal to opposite over adjacent. And what is the opposite? LP. And what is the adjacent? 15. Or PL. LP is the same thing. So PL over 15 is equal to tan 28. Eliminating this 15 by multiplication, because we're dividing by 15. Eliminate it by multiplication. So we have make LP the subject of the formula by multiplying by 15 on the right hand side. So PL is 15 tan 28. We expect it to be a bit around about half or so. So no doubt about 14 so. Well, half of 15 is about 7.5, so around about 8. So 8 meters. So 8 meters. We retain the one place of decimal because each answer in this section is required to be written to 2 significant figures. So we write that as 8.0 meters because we need 2 significant figures. So we need to throw in another figure there. So we are retaining that single decimal place in order to complete the number of significant figures that are required in the statement of the problem. Find Km. That is what we are finding now, Km. Find Km by making use of triangle KLM. There is nothing that tells us that KLM is right angled. We need also LM is equal to 19. Put that in. 19 meters for LM, and we need to find KM, and the triangle is not right angled. Cannot be right angled. Impossible to be right angled because this angle is greater than 90. So the other two will have to have a sum that is less than 90 because 90 plus 90 is 180. The number that is required for the sum of angles in a triangle. So if this is 115, then these two must be less. Each one must be less than 90. Well, as a matter of fact, if we take 115 from 180, that is less than 90. Therefore, these two angles each must be less than 90. It cannot be a right angle triangle. Cannot say sine is equal to opposite over hypotenuse, nor for cosine, nor for tangent, nor can we use Pythagoras theorem. We therefore make use of the rule that is applicable to or in the circumstance that we have two sides of a triangle and the angle that the two sides form. We will make use of the cosine rule that pertains to two sides of a triangle and the angle that they form. So the cosine rule says that the one opposite to the angle is equal to this one squared plus this one squared minus 2 times this cosine of the angle that the two sides form. And right here, CSEC, well, I don't think that they set a trap. It's just that they need the students to be aware that the cosine of an obtuse angle is negative. Therefore, we will have a negative value here to multiply by a negative value here, which will be positive. So we will have all positive terms here. After finding that nice sum, then we know that Km will be the square root of 827, and that is equal to about 29 meters. Triangle LMP is also right angled, and PL was calculated to be 8 centimeters. So there we have triangle LMP, which is this one, LMP. We know that it is right angled because this line, as we stated before, is also on a horizontal plane, and this is a vertical pole. Horizontal meets vertical at 90 degrees, so this triangle is also right angled, and we need to determine the angle of elevation of P from M. So the angle of elevation of P from M is the angle at M because it is taken from M. TF is equal to 8 meters is opposite to the angle, and ML is 19 centimeters. So ML is 19 centimeters, and here we have 8. ML is 19 meters, and here we have 8 meters. What do we have? Relative to this angle, we have two sides. This one is opposite to the angle, and this one is adjacent. Opposite and adjacent implies tangent, and of course, tangent is equal to opposite over adjacent. 8 over 19, which is equal to 0.421, and m is equal to tan inverse 0.421, which is, if we are saying that the tangent of the angle is 0.421, and we need to find the angle, we need to go in the opposite direction of taking the tangent, which is taking the tan inverse, or the inverse, or the reverse of taking the tangent. And that, we have the tan inverse of 0.421, and that turns out to be 23 degrees. There we have a setup which we are required to determine or to solve some problems. And as soon as we have a vector problem with a grid, we know that our work is greatly simplified. We do not mind. For the vectors in this section, we will make use of movements on the grid. Right? So that is what we are making use of. Movement on the grids, because the grid is present and that makes our work easier. So we have OA. All we need to do to find the vector OA is take a look at the movements from O to A. So we have an X component and a Y component. To move from O to A, we say -1, and then we go up by, what do we go up by? 1, 2, 3. So 3. So that is -1, 3. Notice that we are going in negative X direction. What about OB? Here. X movement 1, 2, 3, 4, 5. Although we can plainly see that it is 5, we are just counting 5 to get our minds prepared for when we are not beginning at the origin. So 5, and then we go up by 1. So 5 there, and then we go 1 there. So 5, 1. BA also based on movement, but this time the number of units are not counted from the origin, because we are not going from O to anywhere, we are going from B to A. We will begin at the beginning, which is B, and finish up at the end, which is A. So BA begins at B and ends at A. So look at the X movement. 1, 2, 3, 4, 5, 6. 1, 2. And sometimes my students are saying 6, 2. And I'm waiting for them forever to say -6. And they will not say it, and I will not give them the answer. I stay there and wait until they supply the correct answer, which is -6, 2. Then I move on. And if they do not, then we do not move on. So -6. Because we are going in the negative X direction. 1, 2, 3, 4, 5, 6. And then we are going 1, 2 in the positive Y direction. So that is -6, 2. What do we have there? We are given the information in the statement of the problem that G is the midpoint of AB. And we are saying from A to B, the horizontal movement is 6 units. The midpoint of AB must be located halfway between A and B, which is what? A horizontal distance of 3 units. So we have, this is 6 units. So anything that is halfway between A and B, we have 1, 2, 3, 4, 5, 6 units. So anything that is halfway between A and B must have 3 horizontal units from A and 3 horizontal units from B, halfway. So 1, 2, 3. So right there. Right. So there is where we will have located the point G. And proceed as before in finding the other vectors. So we need BG. Stay at B, then move to G. So we have what? From B to G we have 1, 2, 3, and negative 3, because we're going in the negative x direction. It is not a location, it is a movement. And then we have what? 1 unit. So we go up by 1. Positive y, 1. So negative 1, negative 2, negative 3 for the x, and positive 1 for the y. We could have also made use of the fact that BG is half of BA, right? So BG is half of BA. So what we have for BA, we could have said half of negative 6 is negative 3, and half of 2 is 1. So we could have done that. What do we have? OG, that's the next one. To go from O to G, we go 2 units here, and then what? Another 2 units there. The computer had me, I would say, blindsided a bit, but because they are both 2, then in the end I was not defeated. Remember that moving to the left is negative x movement and downwards is negative y movement. So if the movement would have been in the direction going down, that movement would have been a negative y movement. And as long as we are going to the left, that represents a negative x movement. So we are to be careful when we are making our movements and representing them in a numerical way, because we need to be aware of the implications of the direction as it pertains to the signs. Now we will finish up with our matrices. First of all, we need to have L plus 2m. That is what we need. We have L and we have m. To find L plus 2m, we do 2 times the matrix M and add it to L. So 2 times 1, negative 1 is negative 2, 2 times 3 is 6, and 2 times 2 is 4. No doubt, 2 times 0 is 0. Now we need to add these. Negative 2 to be added to 3, we have a positive 1, then we have a positive 8, 2 plus 6 is 8, then 1 plus 0 is 1, and 4 plus 4 is 8. But we need to be mindful of the fact that when we are just adding matrices, we just need to add the corresponding values. 1, 8, 1, 8. So 3 plus negative 2 is 1, 2 plus 6 is 8, 1 plus 0 is 1, and 4 plus 4 is 8. That's all there is to it. The product is a little bit more sophisticated. We need to find the product of those 2 matrices. So we row by column, row by column, and row by column. So we say 3 times negative 1 plus 2 times 0. There, 3 times negative 1, 2 times 0. The upper with the left, the answer goes to the upper left. So 3, negative 1, 2, 0. Then the upper with the right, the answer goes to the upper right. So 3 3s, 2, 2. 3, 3, 2, 2. Then the lower with the left goes to the lower left. We have 1, negative 1, 4, 0. 1, negative 1, 4, 0. The lower with the left. Now the lower with the right, the answer goes to the lower right. So we have 1 with 3 plus 4 with 2. And then when we simplify that, we get what? Negative 3 here. And of course, 9 plus 4 is 13. Then we are just taking advantage of the fact that these will turn out to be 0. So we have a negative 1 there. And we have what? 3 plus 8 is 11. So negative 3, 13. Negative 1, 11. Just manipulating those matrices can be fun. Now, we need to find the inverse of Q. And to find the inverse of Q, we have Q right here. We do what? 4 multiplied by 1 minus 2 multiplied by 1. That's what we have there. So 4, 1 minus 2, 1. That is 1 over what we call the determinant. This times this times this. So we subtract, and that is what we call the determinant. This minus this. So 1 over the determinant, and we multiply by the adjoint. And the adjoint is formed by exchanging the places of these two and changing the signs of these two. So there we have 4 minus 2 is 2, so a half there, and half to be taken of each one of these. So a half of 1 is half, a half of negative 2 is negative 1, a half of negative 1 is negative a half, and a half of 4 is 2. Now we have this equation. Notice that we have this matrix equation, and notice what we have right here. The same matrix Q. Therefore, if we need to find x, y, we need to eliminate this from the left hand side by multiplying by the inverse of this matrix. Therefore, we multiply by the inverse of this same matrix on the right hand side. Of course, doing that will cause the 4, 2, 1, 1 to be eliminated from this side, and on the other side we have what? The inverse of the matrix being multiplied. Alright, but instead of using the matrix as we have found the inverse right here, instead of using it right as we have it there, we kind of take the half outside, so that when we are multiplying we just use whole number, and then we take half of the entire thing at the end, because it is always easier to manipulate whole numbers than fractions. And I think that the examiners will be delighted to see that students do not just jump and just use the fractions and make a meal of the problem, although it is not impossible to manipulate those fractions and get it right. But we can eliminate any what we would call shadow of difficulty by taking the half right here, and we do the same row by column. So this times this times this, and then this times this times this, and there we have it. So simplify these, and what do we get? We get 2 here, because 8 minus 6 is 2, and negative 8 plus 12 is 4, and we know a half of 2 is 1, and a half of 4 is 2. X is equal to 1, y is equal to 2.